Okay, this first example we'll do together. It's an example of the intersecting chords segments theorem. And all that says is we would take part times part and set it equal to part times part. So we would do AB times BC and set that equal to EB times BD. Okay, so substituting in my values, AB is 5 times 12, and that should equal EB, which is X, times BD, which is 10. 5 times 12 is 60, and that equals 10x. And then we would just need to divide by 10. So x is 6. So the second example, I'm going to have you try on your own. It's the same thing. Part times part equals part times part. Pause the video and see if you get the same answer as I do. Okay, and you should have gotten x is equal to 10. If you didn't, raise your hand and we'll come over and help you. Okay, the next example is when you have a secant and a secant, and these are called secant segments, external secant segments. And this is where you start with the outside segments. So you multiply HJ times the entire segment, GJ, and then set that equal to the external secant segment, KJ, times the entire secant, LJ. And this is the part that a lot of you will get stuck on. HJ is easy, it's 8. But GJ is representative of the entire segment. Not x times 8, but x plus 8. So we would add x to 8, and that'll represent the entire secant segment, GJ. And then when we get to the other side, we take KJ, which is 6, and then multiply it by LJ. And that's easy, 10 plus 6. Again, we're adding the two parts because that equals the whole thing. So 6 times 16. Okay, left-hand side, we need to distribute. 8 times x is 8x. 8 times 8 is 64. And that equals 6 times 16, which is 96. Subtracting 64 from both sides, I get 8x equals 32. So I get divide by 8 and I'll get x is 4. Okay, so the next example I'd like for you to copy down and try on your own. Same exact format, part times the whole thing equals part times the whole thing. Part times the whole thing equals part outside part times the whole thing. Pause the video and see if you get the same answer as I do, and you will get a decimal. Okay, and you should get x is approximately 16.2. That was rounding to the nearest tenths. If you did hundredths, that's fine as well, as long as you're extremely close to 16.2. If you didn't get that, raise your hand and we'll be over to help you. Okay, and the last example is when you only have an external secant segment, or actually a tangent segment, and a secant segment. And this one is going to be your outside part times itself. So the outside segment PQ squared, and you'll set that equal to the outside segment RQ times the whole thing, SQ. And just be careful when you're doing the entire segment that you're not doing x times 5, but that you're doing x plus 5. So PQ squared would be 8 squared, and we'll set that equal to RQ, which is 5, times SQ, which is 5 plus x, or x plus 5. 8 squared is like saying 8 times 8, that's 64. And that equals, after we distribute, 5 times 5, which is 25, plus 5 times x, which is 5x. I'm going to subtract 25 from both sides. So we get 39 equals 5x, and I will get a decimal. When I divide by 5, I get x equals 7.8. Okay, so last example, I'd like for you to try. Pause the video and see if you get the same thing I get. Again, we're doing the outside times itself and setting that equal to the outside times the whole segment again. And you should get x is 5. If you didn't, raise your hand. We'll be happy to help you. Alright, next you're working on your practice worksheet, and then we will do a little whiteboard practice.